Welcome to the Innovators Insider Podcast. I'm Richard Doyle, the user group guy, alongside my co-host, Mike LaFleche, the professor, and we have got a fantastic show today. Michael, this show really gets to my heart here. We're going to be talking about a new offering from Onshape, PCB Studio. Printed circuit board design is something that's really dear to me. I learned how to do that in the old days, back when I was just a teenager. Volunteered to learn at my company to take a class on printed circuit board design, and then spent the next year and a half or so staring at a light table with red and blue pencils and peel and stick appliques and crepe tape, and just it's one of the highlights of my career, even though it happened so many years ago. And the guests we have today, just incredible. So I'm looking forward to a really good show.
Yeah, we have a ton of great guests today, and I won't spoil it all. I don't want to steal my own thunder or anybody else's. So let's just introduce somebody who I consider to be one of the great people in the world of getting Mcad and Ecad brought together. This person's career has spanned many decades, even though it doesn't look like it. We want to introduce Rob Lacey. Rob Lacey, how are you doing today?
I'm very well. I'm not sure about many decades. That's slightly worrying. It's true, but it's depressing. It's sort of depressing to hear.
Yes, it's I've known you for a very, very long time, back when I was a SolidWorks reseller, and you were popping around visiting customers. When you were building the PCB connector tool for that product at the time, and I've known you for many decades. You're one.
We all go back a long way.
Yeah, I was just about to say I'm one of the fortunate ones to have known you since the early 2000s, when we did a little show together down in Austin, Texas, and it's great to have you on the show. Glad to see you here.
Yeah, it's great to be here.
So Rob, what do you do at PTC? You actually work for PTC now, so tell us how you got here, and tell us a little story.
Well, how far back do you want? Well, I'm working at PTC. Well, obviously, I'm working on Onshape PCB Studio, so I'm leading the development of that. And PCB Studio is our new link between Ecad products and Onshape. So Ecad products for printed circuit board design, so Altium, Cadence, Mentor, that kind of thing. So basically, I'm working on bringing that functionality to Onshape, which is hopefully pretty much there. So, but rolling back to where I came from, my history. I'm actually a bit of an imposter in this industry. I'm a mechanical engineer, really. I'm not an electrical guy. My degree's in mechanical engineering. So I started off many years ago, back when I was kind of hanging out with you guys in the world of SolidWorks. I used to design packaging machinery, as you do. So I still walk around supermarkets now, kind of like looking at boxes to see if they're square or see if everything's aligned. That never leaves you. And then ended up kind of putting in SolidWorks in those days in an engineering company. I was packaging machinery company I was working for, which is how I ended up in the whole SolidWorks world, and started trying to solve problems there, mostly actually data management problems in those days. I developed a couple of data management systems because we were developing these enormous grain machines. We had all these problems with kind of, if you change this, you change this. That was the advantage of, parametric systems, but obviously it's very hard to keep track of all those changes. So I ended up initially working in kind of data management, and then moved into one of the things I did. I ended up working for a reseller in the UK, a SolidWorks reseller. And then we developed CircuitWorks, which was the first which was the Ecad Mcad interchange tool for SolidWorks. And that came about as a result of a customer, actually. They were going for full circle, a Pro Engineer customer. And that functionality was in Pro Engineer, they liked SolidWorks, so they asked us for that functionality. And that's how I got into the whole Ecad Mcad game, developing it for SolidWorks many years ago.
So how do you go from being a mechanical engineer to starting a company, writing code like that? That seems like a big jump.
Yeah. I don't know, really. It's kind of, it's like, no one's career is kind of, a plan, are they really? It's kind of like, they just kind of happen, to be honest. I think because I'd done Ecad stuff at university, and I'd obviously done a lot of coding kind of as a hobby and part of my studies. You ended up being the mechanical engineer guy that ends up writing the macros for SolidWorks or for Cadra, which is the 2D CAD system we were using all the way back then. So I started writing kind of add-ins for CAD just to automate things. So to automate the design of tooling and all that kind of stuff. And then, ended up working for a reseller, a SolidWorks reseller, and then doing the same thing for that reseller. And then, then we started building some products out of that. And, customers would come to us and ask for, they'd have a problem that needed solving. And in the case of CircuitWorks, which is the Ecad Mcad system for SolidWorks, a customer came to us and asked for it. And we said, well, look, can we turn it into a product? Rather than charging you a huge amount of money to develop it, we'll charge you a bit of money to develop it, and then we'll turn it into a product. And then the whole product came out of there. So that's how I ended up in the kind of Ecad Mcad space. And then I ended up doing kind of similar things for Autodesk on Fusion, and now obviously here, which is, doing it for PTC, which is great fun, because there's a whole load of new, sexy, exciting things we can do in the world of the cloud that we couldn't do back in the world of the file.
That's right. I remember the early days of CircuitWorks, and it was an instant win, obviously, for people that needed it, to make their lives insanely better. The communication between the two sides was never something that was easy, and this was like bringing everybody together, making sure everybody knew what was going on, keep outs, and the heights of components, and all this stuff was just here, ready to go. You can interrogate things. It was a really great. I almost thought of it as like a Switzerland, like where you have like you bring the two sides together and you have a summit. And you have like this middle place where you're kind of hashing it out, right, and determining what's going on between the two. And I always thought that
the flag's a big plus. That's my one Switzerland joke. But yeah, that's pretty much what it is. It's kind of the guy in the middle, and I think that's where a lot of. I think there'll be some confusion, I guess, about PCB Studio. I mean, it's not a PCB design package,
right?
And nor with CircuitWorks, and it's designed to be a translator. It's designed to bring those two worlds together. So you still need an Ecad tool, your Cadence or your Mentor or your Eagle or your Altium tool. Mm-hmm. But the idea is it's designed to kind of bring that data across into the mechanical world, and similarly, you can start the design of a PCB in the mechanical world, and then. Where you've got the constraints about, about the size of the enclosure, about the height of components, as a mechanical guy, certain things about the printed circuit board. And then the electrical engineer obviously knows, the layout of the routing and the traces and the copper and all those kind of good things. So yeah, it's designed to be the bit in the middle, basically.
Yeah. So in architecting the PCB Studio product, and over the years, if you've come up with this idea, like what are the things that are benefits to an end user, either an electrical person or a mechanical person, for having it centrally located in a cloud-based service versus perhaps storing things on local hard drives and databases and SQL and all that?
There's a whole bunch of stuff, and a lot of which we've kind of not really scratched the surface of yet. I mean, the initial launch of PCB Studio, what we've done is basically said, look, we need this level of functionality, to kind of, to compete with our competitors and everything else. And so, we've got a baseline out, and at the moment, we're not really leveraging the advantage of the cloud. We're leveraging some advantages of the cloud. At the moment, the main advantage is speed and multi-threading. The nice thing, one of the things we can do already is, if systems like this have to build a lot of geometry, they have to create a lot of geometry. And in an old desktop system, you'd have tied that one desktop system up for kind of, 20 minutes, maybe, while it built that complicated board. Obviously, a nice thing we can do in the cloud is we can put all that in the background. That's all happening somewhere in a, inside a mountain in Nevada in a data center, and it's not tying up your PC. So even if it does take a couple of minutes, you can carry on doing whatever you're doing. You could carry on using Onshape whilst your board's building. And also, you can multi-thread that. You can throw that to as many different computers as you want. You're not limited to just one computer on your desktop. We can get as many computers as you want doing things. So we can make things happen a lot quicker. So that's the cloud advantage we've got currently. But going forward, there's a huge amount of advantages it brings us. I mean, the one obvious one is Ecad is moving to the web too. So at the moment, PCB Studio can upload files and it can download files, but that's not the Onshapey way of doing things. And Ecad is moving to the web too. So you've got systems like Altium 365 and Flux.io and a whole bunch of others. Upvert is another one that are now cloud-based. and we're talking to these customers, we're looking at these systems, so we can do, browser to browser, tab to tab, Ecad data exchange.
Right.
And then apart from the convenience of not downloading, uploading files, you've also got this kind of neat thing where we can go inside each other's worlds. So from Onshape, you'd be able to go into, say Altium, and, if you could log into Altium, you could view your projects in Altium and you could bring them straight in. So rather than doing file upload, you can go into Altium and bring that data across. So that gives you a major advantage, just in fact you're not losing stuff. But you've also got, once you get to that kind of world, you've got this sort of single source of truth idea where you can have one model effectively. You're not dealing with copies of stuff. Back in the world of files, obviously, you've got one copy of a file, your Ecad guy's got another copy of the file, one's called Rev A, one's called Rev B, one's called Rev B _ final, the other one's called Rev B final last, and as we all know, there's problems. And we're talking to a few Ecad companies about having one master model effectively. So somewhere in the web, there is a model of that board, and we look at it from a mechanical perspective. We want to know how big it is, what shape it is, will things fit? And obviously the Ecad guy wants it from Ecad's perspective, but it's the same model with the same versions. And then we know who's changed what and when, and there aren't multiple copies. It's just different views of the same thing.
Yeah, it seems like almost like a funhouse mirror, right? You
Yeah.
the same person, the tall skinny guy or the short squat guy, but it's still the same person looking at it in two different orientations.
Yeah, absolutely. Yeah, and again, linking to the cloud systems, we can move beyond geometry. Certainly we've been playing recently with Altium's API, and we can get a whole load of information. We can get stock information, we can get obsolescence information, we can get data sheets, we can get pricing information. So we can theoretically bring that data into the Onshape world and say, well, look, when you're building a board in Onshape, it would know if a component's about to go obsolete, or it would know how much it costs, or be able to link to suppliers, that kind of thing. So there's a whole bunch of stuff you can do with that as well.
Yeah,
and then
sky's the limit.
Yeah. Finally, actually, another really interesting area that we've played around with a bit with some experimental code, but kind of is machine learning as well, which is where we can obviously learn from the decisions made by others, which is something, again, with a desktop system, you're completely siloed. So you can typically systems like PCB Studio have a list of Ecad part numbers and the Onshape document, the Onshape model it relates to. So we're saying, if you upload something called 0402R, we know you want to use this Onshape model of a 0402 resistor. And currently that's taking a kind of human to teach it. And it was the same with systems like CircuitWorks. You'd have to teach it that. You'd have to say, okay, well, these systems can build their own geometry, but if you wanted to use a detailed model, if you wanted a kind of sexy looking model, you'd have to teach it and say, okay, whenever you see this part number and it's a DigiKey part number or whatever final part number, I want you to use this model. What we can do now is we can look at the decisions that other people have made, kind of, without giving away any of their personal data, of course. We can go, well, okay, when somebody has got this part number, 90% of them choose this model. So I'm going to suggest this model to you.
Right.
So we can start to very quickly build those data patterns and then hopefully, make useful suggestions in future. I mean, all this is, looking ahead, of course. We haven't got this functionality in there now, but this is where we'd like to, the possibilities of where we'd like to go with it, because, suddenly we have all this, we have all this data and it's all live. Yeah, so we can instantly do all these amazing things that we couldn't do in the past. So it's really pretty exciting that what the cloud brings.
Amazing. Yeah, it really is. I'm excited for the future for this, for sure. I mean, like when John Hirschtick says we're still in the early days of CAD, this proves it right here. Like this is still the very leading edge of where we can go.
Yeah, absolutely. Yeah.
And I'm excited about the future too, but I'm also really excited about the present. And I cannot wait to get my hands on PCB Studio. I think the first thing I'm going to do is create a fully detailed, all the way down to the, individual transistors, everything possible with highly detailed models, because that's just the kind of guy I am. So.
You got to render it. You got to make it look.
Oh yeah.
Well, yeah. You can render it now, of course.
Yeah. Exactly.
Yeah.
It'll look great. what else would you say? Were there any surprises, over the years when you started talking to people about connecting Ecad and Mcad? Were there things that were like surprises, like, oh, why would somebody care about that, or why would somebody want to do something a certain way? Any
I think the main, I guess it's not really a surprise, but I think the main challenge is kind of how it's always lagged behind, because the formats in the center have always kind of lagged behind. So you're always playing catch up. If you look at what if you take your cell phone, if you take your iPhone and hit it with a hammer, which is a bad idea, but if you were doing that, and you look at what's inside it, it's basically a flex rigid board. It's a board made up of layers of flexible and rigid kind of materials. So it's basically like a board with ribbon cables, but you fold it into, it all folds and unfolds. And for a long time, the data exchange formats that we use, we look at these specific data exchange formats between Ecad and Mcad, and IDF was the very common one that was used for years and years and years. That can only really describe a green rectangle, and what is now inside your cell phone is not a green rectangle. And now a lot of companies, and again our team's one, are looking at their software is beginning to support completely non-planar PCBs, where you're having a circuit, you're tracing the electrical traces on a curved surface.
Right.
So that's being used in automotive a lot, where with the inside of your steering column might have the electrical kind of routing the traces kind of printed on the curved plastic molding, and no file formats can support that currently. We're involved with a group, a ProStep EDMD, which is a group which is trying to push those problems forward, really, with trying to catch up, basically, because for a very long time nothing happened. IDF, everybody used IDF. IDF was kind of the standard. We still support IDF now, but we're trying to rapidly catch up with IDX so we can start supporting this stuff. Flex rigid boards, multi-layer boards, things that fold, things that unfold.
Yeah, things smaller. Yeah, we need to deal with.
So yeah, I mean, and you've always got, we're always playing catch up. I think that's the Ecad technology is kind of there, and then a few years back, the interchange technology is a couple of years behind that, and then obviously, all the guys like us trying to write the software, we're ending up a couple of years behind that. So it's always a game of catch up, really.
Yeah. Hey, I bet the audience would like to see what we just built. Maybe we can add our friend Jay Tedeschi to the call. Let's bring him in. And Rob, if you don't mind staying along and adding commentary along the way, I think that'd be great.
Of course.
Hey, Jay.
Hi, Jay.
Doing good. It's an exciting time. Happy to see the PCB Studio product come to light for everybody. And why don't you tell us? I think you've been on the show before, Jay, with us, and it was a great interview. We'll have to put a little note here in the podcast here to reference back to that. You should definitely give it a watch. A lot of good stories.
That was a lot of fun.
Yeah. So what are your impressions of PCB Studio, and what have you been doing with it in the last few months?
Using it over and over and over and over and over again. It's very cool. I can't think of any better way to describe it. It is, as Rob touched upon, having the advantage of being cloud-based. It becomes evident very quickly once you start using it, especially with regards to the library. The library is a little obscure concept initially, but I'd say most of the users are going to grasp it quite well within 30 minutes. You start using it, you're like, oh, wait a second, I could do this. And the advantages of the way that we are configured right now, the way PCB Studio interacts with data from PCB design tools, is it becomes self-evident very quickly.
Great. So you're going to show us a little demo of, perhaps how the whole workflow works. Maybe you can, kind of set it up for us, and then you can show it to us.
Yeah. So I was working with one of the guys here on some data for our Arena product. and we wanted to show arena integration. And I was like, well, why don't we just weave like a multi-pronged story here? Why don't we, instead of just showing arena, why don't we show like integrate in there? The data in question was a handset, a GPS handset from one of our customers. And I was like, why don't we just weave in? I mean, the natural like tangent of this story is that handset's got a printed wiring board in it. So why not, tell the story like front to back? So that's what, I basically did that front end for him. And here's the front end. So what we're looking at here is the interior of the handset. Most of the body has been turned off at this point. But what we've done is created a blank for the wiring board itself. And we need to create a keep out. Keep outs, keep ins, these are all standard data formats within IDF. And as you can see, I just named that part down in the browser. We've named it place keep out, which is the IDF tag for a keep out. So we can now now that I have the board and the keep out defined, we can synchronize that data here in PCB Studio. Really cool thing here is that, especially for boards that have, you have components on the top and bottom part of the board. That was why just now I selected the plane, the top plane is the reference plane. Because now when I take this data and send it over to the tool that I'm going to use for doing the PCB design, which in this case is Altium Designer, it knows that this display is on the bottom portion of the board. And you're going to see in a moment, I'm going to say, all right, all I did here was start a new board. There's nothing created yet. I'm going to pull in the IDF data that we just created from PCB Studio, board main, and it will immediately identify once I tell it what I want to bring in from that IDF file. And it immediately recognizes that that's on the bottom layer, that keep out. And right away, we now have, here is our board and our keep out.
I'm going to stop you there just for a second, because this is a cool workflow. A lot of people, I think, might be surprised that you can go in this direction, whereas a lot of, Mcad people are usually consuming the circuit board data, but it's a true two-way street here, right?
Correct. That's what we wanted to do, because you can't define for a lot of these companies, the Mcad design is going to drive the envelope size for the board. But in some cases, you're going to have the board defined first. And so the whole point of PCB Studio is to allow our customers to work however they wanted to work. If you want to start with the board in if you want to define that envelope in the context of the Mcad design, you can do so. If you want to go the other way, you can do so. Right. Main point being that, at all points in time, you can share data back and forth. PCB Studio is like a mezzanine tool. It's a handshake between products. And, we don't care what PCB design tool you use, as long as it supports IDF and IDX, we're going to support that, input and output from those products. Right.
Yeah, I'll let you keep going then.
Okay. So next step, and this is kind of a standalone little thing, but I decided to throw this in here. We're going to take a look at just the remember I was talking about the library itself. So a library administrator essentially determines where the library components are going to go. So in this case, we're working on the handset. So I'm going to select that handset folder. So
and that's right in Onshape. Yeah.
What's that?
That folder's in Onshape.
That's correct. So all of these components are now in a cloud accessible location. As you can see, like Rob described, they're just rectangles initially. But for those components where we may have an interface between the Mcad and Ecad design, my own personal philosophy has always been that instead of converting every component on the board to a detailed model, the only ones I really need as a detailed model are the ones where there is an interface taking place between, for example, that flexible keypad where you're pressing buttons on the handset and the B3U switch here. So now that we've done that, we've created that library component. We've already defined that now in the library. So whenever it sees a B3U switch come in from whatever source, and there are all the B3U switches on the top side of the board, or bottom side of the board rather. Whenever it sees those those switches come in from any IDF source. As long as they're brought into this handset project, it's going to convert them automatically into that detailed model that you saw. So what we're doing now, the board is finished. We're exporting the IDF. We're deciding which content on the board itself we're going to send over to Onshape. What matters to us? Do we want traces? Do we want, all I really need is the physical components on the board that I'm interfacing with in my mechanical assembly. So I'll select those files. We'll pull them in. And this is the really cool part. Watch this. When I go to the bottom of the board, all the B3U switches came in because I had already gone into the library and said, when you see this part number, this is how I want you to display it. You can also, on the fly, you can do these detailed part substitutions. So I'll just cruise into the folder where I've defined where I want to keep all that content. We'll throw a USB switch in there. Or USB connector, sorry, and do the same thing for the SMA. Probably could have edited this part of the video. It's redundant, but this is
this is cool. I mean, this is cool.
Realistic. This is what you'll have to do. So
yeah, this is Switzerland area, right? Yeah.
And
I am so excited.
So I was going to say, Richard, these are company specific. Is the way these rules work effectively. So Jay's creating these rules. Everybody in the company looks at the same kind of library document that contains all these rules. So now if anybody else within the company uploads another version of this board or a similar board that uses the same part number from Altium, they'll get that same detailed model. So, if one person, it works across the entire company. That's the way we.
Yeah, and as I was saying, per my personal philosophy, it stands to reason that if I have a board that has an SMA connector for an antenna, a USB connector, buttons, whatever those components are on the board, which interface with the mechanical design itself, it makes sense that regardless of the board, it doesn't have to just be this one. It's every single board that company does. Pretty much every time I'm going to want I want the USB, I want the SMA, I want to see the detailed versions of each of those components.
Yeah, it makes a lot of sense. I remember a lot of the issues with some of the desktop software was everybody had to manage these libraries themselves. And it was difficult to work in a PDM type environment as well. Right. And this, because the CAD and the PDM are together, it's a non-issue whatsoever.
So and Jay, while I respect your philosophy towards that, I'll have to disagree slightly, because when I get my hands on this, every single component is going to be detailed.
Oh, I did the same when I did that. Do you remember the flight control, that little the guidance system that I did for the 5-meter wingspan glider?
The Render Studio.
At the time, we were just getting to beta with Render Studio, and I was like, I'm doing every component on the board because I want to do a rendering. It came out fantastic, but when you have a board that's that dense, I'll just warn you ahead of time, you're going to be in the library for quite a while.
Sure. And like you say, I mean, for most companies, it doesn't make sense to have a detailed representation of every single component on the board, but it sure is fun to have that ability.
Oh, and it looks, when you get to Render Studio, it looks amazing. I mean, that's another thing. So at this point, we'll now start working on the assembly again, and I'll bring in the antenna, which attaches to that SMA connector. At this point, it's just Onshape. So, mate connectors, I can use in context design so that I have features on the mechanical design which reflect position of components in the electrical design, or vice versa. You basically have all of the same design tools that you use and methodologies that you use when you're using Onshape can be used with this Ecad data. It's no different whatsoever. I'm about to show you, one of those design methodologies right now. So we've seen that we have an interference as the board came over from the Ecad designers. We have the USB connector, which is out of position, and the SMA connector actually causes an interference. Now, again, there's, numerous ways to solve this. I choose to go into the assembly itself because I can ensure that I'm not going to be moving these components at any distance which does not reflect the grid snapping intervals that are over in the Ecad design tool. So I don't want it at 3.15 millimeters. I want to move this thing exactly 3 millimeters or exactly 3.1 millimeters, matching the grid snap that I use or the Ecad team uses when they're doing their design. So changes are made to the printed wiring board. We bring them in. The interferences and misalignments are, basically now taken care of. Only other thing to do now is to synchronize the data from Onshape to PCB Studio. You'll see those two components move. You'll see those two components move.
There.
And now we synchronize this back with the Ecad team. Like, okay, we had to update the positions of these things, so we'll send you that data back.
Yeah. No, that's great. That's a great workflow. I like, you can go back and forth. You can communicate. It's really the Onshape way, right? We always talk about collaboration and communicating and working together, and this extends, the family to the Ecad.
It's in very short order. It's going to be super awesome once, these companies that are now, just starting to break into cloud-based Ecad design tools. Altium 365 is that's the first step in the right direction.
Yeah.
But, as Rob pointed out, there are several vendors right now that are, doing similar development efforts. So, in not a very long span of time, we're going to have a lot of options for, as Rob pointed out, just seamless transfer of data.
Yeah. And that's where it's going to get really, really exciting, hopefully.
It's going to be awesome.
Yeah.
It's very cool right now. It's going to be awesome.
Yeah. It's cool because it works.
Right.
It works without you having to be juggling and, chewing gum and Scotch tape and all these things. You don't have to worry about it. It just works. And that's step one.
I mean, as Richard pointed out, I started back in the 80s working for the DoD doing weapon system design for the US Navy. And all of those systems had, at the time, we were doing multi-layer boards on these huge glass tables that were lit from they were doing the boards at 8x magnification with the tape and then I remember going to multi-wire boards. But point being that when we first started using CAD, which was at that time Computer Vision CADS 3 CGOS, so you had any color you wanted to design in, as long as it was one of 256 shades of green. But it was a struggle. And when I look at, what we're able to do nowadays with the design tools, and it's mind blowing by comparison to, what we had to do back then. I was talking to Greg Brown, who runs product management here at Onshape. And we were discussing something that nobody has to think about anymore. You have any number of ways of creating construction planes or work planes. Back then, you had to have your Hewlett-Packard RPN calculator with you, because the only way to create a CPL, a construction plane, was to trig it out. You had to say, okay, I want the origin of the plane here. I want a point on positive X here, and I want a point on positive Y there. So you were doing a lot of trig with your calculator to define a CPL. And then once that was defined, okay, now I'm going to create a sketch on that CPL. But it's just nowadays, and okay, well, I want this plane and I want it to pass through this point. And I want it to be aligned with, it's mind-blowingly efficient nowadays.
Yeah, it is good. And I'm glad that it's that way too.
Yeah.
You and me both.
We've got a studio full of people here that have seen a lot of really cool stuff over the years.
Yeah, there really is. And I think, Richard, that person has seen a lot of the stuff over the years as well. He's a great friend of ours. Maybe we should pull him in, but we should probably, just for the sake of space on the screen, we'll thank Jay and Rob for joining us, and we'll bring them all back, at the end of the show. But
so I can't leave.
Sounds good.
You're here for good.
All right.
All right. We'll see you in a few minutes.
Sounds good.
All right. Thanks again.
All right. I'm excited about our next guest because I've known this man for nearly 20 years now. It goes way back to the early 2000s when I was reading some of his articles that I found absolutely fascinating and just wonderfully written. And I reached out to him to see if he would be interested in keynoting a little event I was holding down in Austin, Texas. And he agreed, and he came down, did a great job. We've been friends ever since. Everybody, please welcome Jeff Rowe.
Thanks, Richard. Yeah, we have known each other for a few years, haven't we? In multiple lives.
Hey, Jeff, welcome to the show.
Yeah. Yeah, it's great to be here. I've really enjoyed the various podcasts you've done thus far, and I'm just happy to participate.
Great, we appreciate that. So, tell me, do you remember giving that keynote back then?
Oh, yes. And at that time, things have changed, of course. But Lance Armstrong was the king of Austin.
Yes, he was.
Of course, things have changed since then, but that was a really great conference, and I had a great time doing it.
Great, I appreciate it. Well, we're glad to have you here on the show. You've had some exposure to PCB Studio. You've been helping Onshape out, doing some writing, doing some reviewing.
Yeah.
Can you give us your first impressions of PCB Studio? What do you think?
Well, I'm going to step back one step. I have to agree with Rob. I mean, like everybody, I think your career evolves, and when you're young, you have no idea where it's going to go. I started life as an industrial designer, and I designed everything from starting with surgical and optical instruments for arthroscopic surgery. I worked for Samsonite Luggage for a while. Yeah. I designed commercial ice machines. Actually, one of which is still in almost every 7-Eleven around the country.
Nice.
And this is it goes so far back. I was using AutoCAD 2 something, and that was my first exposure to CAD. With the puck, and it was very difficult to use.
Graphics digitize a tablet.
Yeah. And but over the years, in my various design capacities, I've used AutoCAD, SolidWorks, Pro Engineer, Onshape, and Fusion 360. But I've really come to love Onshape primarily because it operates on anything, from an iPad to a Chromebook. I don't deal with Windows anymore, but I'm really happy with the other platforms that it runs on. And again, go back to the career evolution. I eventually got into trade publications. So over the years, I worked for and written for Mcad Cafe, Catalyst, Desktop Engineering, Engineering.com, and others. And I still do some of that today. My career has really dialed back, especially after COVID. But I do like to remain active in the engineering software community. So that's why I've really been glad to be associated with Onshape the last year or so, and helping them with some consulting and writing projects. Now, as far as PCB Studio goes, I was very interested in it because, as we all know, there is really no such thing, for the most part, as a purely 100% mechanical product anymore. Just about every product you can think of has an electrical, electronic, and/or software component. And PCB Studio is a big step in the right direction, especially for Onshape, in helping integrate Ecad and Mcad, two things that historically have been kind of disconnected. So it's been really interesting for me as kind of I'll say an Ecad novice to really kind of to get a better feel for how a tighter connection and integration can be made between Ecad and Mcad.
Yeah, it's such an important thing for a lot of our customers to have this connection. What are some of the things, Jeff, that you see, in the your many years in the market, are good things that people will appreciate about PCB Studio? I think we've seen a lot of it, but maybe in your words, it would be helpful, I think.
Well, it's not so much just purely a tool. I think it helps change a historical practice. In my mind, it provides three things. Of course, it better integrates electrical and mechanical design. I love the way that it has the ability to easily exchange data without loss between electrical and mechanical CAD. And I really like the bidirectional associativity that it provides between Ecad and Mcad. And it doesn't get down to the board design level, but right now that's okay. I mean, I know you're going that direction, but I do like the fact that you can really check and be assured that electrical components will in fact fit inside a mechanical enclosure.
Yeah.
And that's a huge step forward.
Yeah. And some of these components are hard to get, long lead time components in many cases. So making sure that it actually works and finding the problems earlier, kind of like the agile kind of design flow is failing fast. And the Ecad world has been more closely related to software than the Mcad world, right?
Yeah.
So they've already got this. They already understand this.
Yeah.
And, of course, the mechanical world is taking a look at this agile process.
That's right. That's right. And I like the fact that it's actually usable intuitively for a non-expert like me in Mcad or Ecad. I'm sorry, Ecad. And I really appreciate that.
Yeah. I think I'm in the same boat. I'm not a Sparky. I'm typically more on the mechanical side, but I understand how what these components do and how they flow into Mcad, of course. But it really is nice to have like this Rosetta Stone kind of place where you can go in and make the connection and
that's right
and work that way. So
that's right. That's right.
And the one thing that I haven't heard anybody mention yet, that's really important to me, or would be if I was still working as a designer, is the ability then to have a full, complete bill of materials for your entire product, instead of having separate bills of materials for electrical components that might be mounted on the machine at some later time, and that happens. You don't often mix those electrical with the mechanical in your CAD designs. But now having that ability to bring in all of that metadata, all of that information for all of those components for every single circuit that is in that machine gives you a complete bill of materials. I find that to be incredible.
And I like the fact that you could use these models now for creating images for marketing, service manuals, assembly instructions, and so on.
Yep.
3D printing.
3D printing,
Yeah, doing your heat analysis. You put a heat sink on. Is this going to work in my area? There's systems out there in our app store for doing simulation, of course, that this would all work with. So there's many reasons and use cases for having this level of detail in your mechanical design.
Yep. Well, I knew this was a big deal when we started. I think we've all determined it's even a bigger deal than we thought.
Maybe we can bring everybody back and
for some final thoughts. I like that idea.
I think that's a good idea too. So welcome back, Jay, and welcome back, Rob. If I can get you, you're in.
There I am. Right.
There you are. Yeah. So just look at this crew.
Yeah, I know. I suspect that I'm the elder here with my 40 years. No? Okay. Well, then my 40 years combined with Jeff's, 50 then?
Almost 50. Yeah.
Wow. We're already near 100 years experience in just two of us. And then the three young folks here. We're looking at about 150, 160 years of experience in the engineering fields here. I don't know how many times you get to see that in a podcast.
Wow, all of a sudden, I'm really tired.
I'm usually the old guy on the show too, and not when I'm on with Richard, of course, but when I'm with my other colleagues at the office. But it's nice being the spring chicken here on the call. no, all respect to you guys, obviously. But it's so nice to have everybody here, and I think to Rob, thank you for being the Ecad, Mcad, Cupid, for getting us brought together to making a product that will enable less mistakes. I mean that's really what this is, right? You're gonna make less mistakes. You're gonna get products made faster, and
That's the hope. That is the hope. And what's amazing, just talking about how old we all are, is the fact that we're still doing new stuff. I mean, that's one of the really exciting things about working in this industry. The fact that every day you're learning, which is we get the fact Jay was talking about the ancient systems in use back in his day, obviously way older than me, but but it's great that we still get to do new exciting stuff because the industry keeps moving and we keep having to try and keep up.
Right.
Yeah, Jay, you have an unprecedented level of historical knowledge and engineering. It's always great to hear the stories.
Well, this is relevant because of the Artemis shot that hopefully will be going off at the end of the week. But I grew up in the 60s with the space program. So it was an intriguing and exciting period in time. And that's all I wanted to do. Right away, I was like, I'm going to be an engineer. That's what I want to do. That's just beyond cool. I mean, to work on stuff like that. And fortunately, I lived in New London, Connecticut, so we built nuclear submarines right across the river. And on my side of the river, we basically took a boat and turned it into a weapon because I worked at Naval Undersea Warfare Center. So that's where we did all of the sonar and the self-protection systems and periscopes and all the cool stuff. It was fascinating. It was, it's a great industry to be in, and the tool set just supports that. The tools keep getting better, and we keep making better and better products.
And I can't wait to get my hands on this one. In fact, Jay, I just chatted, sent you a private chat with my my Onshape CAD username. Please share some data with me. Share anything that you can that I can start taking a look at PCB Studio and start converting those things into real representations of every single component.
Yeah, maybe in the show notes we'll put a link or two to some public Onshape models that have come through this as well. We'll I'll take it in action to do that. And for the next generation of people, Jeff, you see it, right? You work with students,
Yes.
All right.
Yes.
So, what do you see, is the, interesting for the next generation of folks, in the industry, as I think we're still first getting started, just like John, Herstick says, even though we're 50 years in.
Yeah. Well, I think the historical mechanical engineering curriculum is going to change drastically. And I've seen it over the last several years myself. It's not just strictly mechanical. We're bringing electrical, electronic, software, and sensor disciplines into a historical mechanical engineering curriculum. And with what you guys got going here with PCB Studio, you're right in step, and I think you're a step ahead of your competition at this point.
Great.
Yep. The future is all about the IoT.
Yeah, because I really think that with Onshape's philosophy of agile design, I think you're doing a really marvelous job, and will only get better in promoting communication, collaboration, and cooperation between various Ecad and Mcad teams, disciplines.
Should be exciting.
Yep.
All right. Well, I think this was a great show, everybody. Thank you again for joining us.
I enjoyed it.
Let's give everybody a wave. So we get a nice
absolutely.
But looking forward to everything that comes forward from this project moving forward, and I wish everybody a great rest of your summer and happy fall coming up.
Thank you.
Yep. Yep.
You as
Thanks
well.
everybody for being on the show, and to our listeners, please subscribe to our channel here so you won't miss an episode, and give us a like if you like what you see. We appreciate it. Thanks everybody.